In this video, we see how to compute the moments of an autoregressive process of order 2, in which we have that yt is equal to phi1 that multiplies yt minus 1 plus phi 2 times yt minus 2 plus some random white noise process. So et is not normally distributed with mean 0 and variance sigma square. So first of all, we take the mean. So we compute the expected value of yt. That will be equal to the expected value of phi 1 yt minus 1 plus phi 2 yt minus 2 plus et. First of all, the expected value of et will be equal to 0. Then the expected value of phi1 and phi2 will be phi1 and phi2 themselves as they are constant, and the expected value of yt will be the same for each period as we are considering a stationary process. So this will be equal to mu, and then it will be equal to phi1 mu plus phi2 mu. So this equality holds whenever mu is equal to 0. Then we compute the autocovariances. So the first autocovariance will be just gamma 0, and then that will be the expected value of each element multiplied by yt, because we are subtracting the mean that is 0. So to compute the autocovariance, we'll just multiply by yt. So we have that the first autocovariance will be equal to the expected value of yt squared, that is equal to phi1 that multiplies the expected value of yt minus 1 times yt plus phi2 that multiplies the expected value of yt minus 2 times yt plus the expected value of et yt. So this will be just equal to the first autocovariance, the autocovariance of order 0. This will be equal to the autocovariance of order 1, so we call it gamma 1, and this will be equal to the second order autocovariance that will be equal to gamma 2, and this will be equal just to the variance of the white noise. So eventually we have that gamma 0 is equal to phi1 that multiplies gamma 1 plus phi2 that multiplies gamma 2 plus sigma square. So we have sigma square here because we are multiplying et by yt, that is equal to phi1 yt minus 1 plus phi2 yt minus 2 plus et. So the expected value of this multiplying this is 0. The expected value of this multiplying this is 0. The expected value of et, the expected value of et squared will be sigma. So we proceed to compute the other covariances of order 1, but to do that we need some tricks. In this case, it's a little harder than the case of autoregressive order of order 1. So to do that, to compute the first autocovariance of order 1, we need to do some extra steps. So first of all, we have to compute the autocovariances of order j. So it will be the expected value of the product of yt and yt minus j. It will be equal to phi1 that multiplies the expected value of yt minus 1 and times yt minus j plus phi2, the expected value of yt minus 2 and yt minus j plus the expected value of et and yt minus j. So the expected value of this is 0 because in any yt minus j does not appear et. For the other stuff, we said that this, it will be equal to the autocovariance of order j. This one will be equal to the autocovariance of order of order j minus 1, and this will be equal to the autocovariance of order j minus 2. So basically we we are left with this formula that is gamma j is equal to phi1 gamma j minus 1 plus phi2 gamma j minus 2. So to have all the elements we need, then we divide all this by gamma 0. In this way, we are left with a rule, with a function for the autocorrelation. So the autocorrelation will be that the autocorrelation of order j will be equal to phi1 multiplies the autocorrelation of order j minus 1 plus phi2 that multiplies the autocorrelation of order j minus 2. So we need to do some tricks here. We have that, what is the autocorrelation of order 1? It is just equal to the first autocovariance of order 1 divided by gamma 0. So it implies that gamma 1 is just equal to rho 1 times gamma 0. And this is the same for the second order correlation. It will be gamma 2 over gamma 0. That implies that gamma 2 is equal to rho 2 times gamma 0. In this way, if we use then this function, we have that the first correlation, rho 1, is equal to phi1 that multiplies rho 0 plus phi2 that multiplies rho minus 1. Since the autocorrelation function is a symmetrical function, this will be just equal to rho 1. So we have that this is equal to phi1 rho 0 plus phi2 rho 1. So if we manipulate this equation, we are left with rho 1 that is equal to phi1 divided by 1 minus phi2 that multiplies rho 0. Then we have that rho 2 is just equal to phi1 that multiplies rho 1 plus phi2 that multiplies rho 0. We already have computed this one, that is equal to this stuff here. So we have that rho 2 is equal to phi1 squared rho 0 divided by 1 minus phi2 plus phi2. This is because rho 0 is just equal to 1, because rho 0, it is just gamma 0 divided by gamma 0. So it is equal to 1. Then we take our formula that we computed in the beginning, that was gamma 0 that is equal to phi1 gamma 1 plus phi2 gamma 2 plus sigma square. In this formula we substitute with the way we define gamma 1 and gamma 2. These are these two. So we substitute in this formula, we put this here. Read that carefully. So we have that this stuff is here is equal to gamma 0 that is equal to phi1 rho 1 gamma 0 plus phi2 rho 2 gamma 0 plus sigma square. Then we substitute this rho 1 and this rho 2 with this formula here. So be really careful in the computation. Then we have that this is equal to gamma 0 plus phi1 squared times rho 0 divided by 1 minus phi2 times gamma 0 plus phi2 that multiplies phi1 squared rho 0 divided by 1 minus phi2 plus phi2 plus gamma 0 plus sigma squared. Then we proceed on computing. We have that gamma 0 is equal to phi1 squared rho 0 divided by 1 minus phi2 gamma 0 plus phi1 squared rho 0 divided by 1 minus phi2 plus phi2 squared gamma 0 plus sigma squared. We keep on computing. So we are left with, we just take this on the left hand side because we have some common factors here. So we take it to the left. And then we have that gamma 0 that multiplies 1 minus phi1 squared rho 0 divided by 1 minus phi2 minus phi2 phi1 squared rho 0 divided by 1 minus phi2 minus phi2 squared is equal to sigma squared. We take the common, so we have these two in common right here, and then we multiply this stuff for this and this. So we have that all divided by 1 minus phi2. There is 1 minus phi2 minus phi1 squared rho 0 minus phi2 phi1 squared rho 0 minus phi2 squared times 1 minus f2, that is equal to sigma squared. We go on, we keep going, and we have that this is equal to 1 minus phi2 minus phi1 squared rho 0 minus phi2 phi1 squared rho 0 minus phi2 squared plus phi2 third cube divided by 1 minus phi2. That is equal to sigma squared. So in the end we have that the autocovariances will be gamma 0 that is equal to sigma squared that multiplies 1 minus f2 that is divided by 1 minus phi2 minus phi1 squared rho 0 minus phi2 phi1 squared rho 0 minus phi2 squared plus phi2 cube. Alternatively, we can rewrite it as the formula stated by the book, the time series book Hamilton, that is reported as sigma squared that multiplies 1 minus phi2 divided by 1 plus phi2 that multiplies 1 minus phi2 squared minus phi1 squared. These two denominators are equal. You can, if you want, you can compute and verify that they are equal. So we remember that gamma 1 it is equal to phi1 gamma 0 plus phi2 gamma minus 1. Since this is symmetrical, this is equal to gamma 1. So we have eventually that gamma 1 is equal to phi1 gamma 0 over 1 minus phi2. So to compute gamma 1, we just multiply sigma, we just compute sigma squared times 1 minus phi2 1 plus phi2 times 1 minus phi2 all squared minus phi1 squared, that is gamma 0, times this factor here, phi1 over 1 minus phi2. Then we have that gamma 2 is equal to phi1. We just use this formula, the general formula we compute in the beginning. So we have that gamma 2 is equal to, it was this here, gamma 2 is equal to phi1 gamma 1 plus phi2 gamma 0. And the general formula will be, as we said before, gamma j is equal to phi1 gamma j minus 1 plus phi2 gamma j minus 2. At the same time, as we computed before, we already computed the autocorrelation function, so we are over. Thank you for the attention.